Okay, this video is going to try and talk through some past paper questions to show you how easy it is to get answers when you know the formulae that you have on the formula sheet. So first of all, question 1. Steady current passes through a torch for 6 minutes. Calculate the charge that flows through. Well, straight away, I look at my formula sheet and I write down that current is defined as delta Q over delta T. Now, first of all, that gets me a mark before I even begin. I rearrange it and I say that the amount of charge must be equal to I times T. I plug in some numbers. I is 0.25. T is 6 minutes, but of course I need to convert that to seconds, so I multiply by 60, and I have an answer of 90 coulombs. Job done, 2 marks, really straightforward. Now says the torch bulb is now connected to a battery, negligible internal resistance, which is good news, so we can forget about that part of the syllabus. Battery supplies current of 0.25 amps for 20 hours, and this time the energy transferred is 9.0 times 10 to the 4. Calculate the potential difference. Let's write down potential difference is work done per unit charge. That gets us a mark straight away, straight from the formula sheet. What's the work done? Well, it tells me the energy transferred is 9.0 times 10 to the 4. What is the charge? Well, this time it's not exactly the same as above. We need to do 0.25 amps, that's the current, times the time, which is 20 hours times 60 minutes times 60 seconds. Let your calculator do all of that hard work, and you end up with an answer of 5.0 volts. Again, really straightforward. What's the power of the bulb? Well, power, electrical power, is V times I, straight from the formula sheet, so that's 5 times 0.25, which gives us an answer of 1.25 watts. One question, 5 marks, really straightforward. Question 2. On the axis below, it wants a current voltage characteristic for a filament lamp. Doesn't need any values for current or voltage, just wants the shape. So this is our S-shaped curve. There's 1 mark for the curve in the negative quadrant, 1 mark for the curve in the positive, and 1 mark for it passing through 0. 3 marks, really straightforward. Explain why the characteristic has the shape that we've drawn. Well, that's worth 3 marks. So we need to be a little bit careful that we get all of those 3 marks. So first of all, we need to say that the current passing through heats the filament, so there's a heating effect due to the current. We need to talk about the fact that as the temperature of the filament increases, that increases the resistance, and that gives this effect that voltage and current are no longer in proportion even. V and I no longer obeys Ohm's law because the resistance is increased. You can see the change in gradient of the graph. And if you wanted to add that that's the same for both positive and negative voltages, then that would be worth mentioning as well. Each of those 4 points is worth 1 mark, but obviously you're only allowed a maximum of 3. Over the page, it says the current voltage characteristic of a filament lamp is to be determined using a data logger, the data then being fed into a computer. Draw a circuit diagram and state what's varied to produce a range of values. Well, I'm going to need some kind of power supply, some kind of cell or battery. I am going to need to have a variable resistor so I can vary the PD and current across and through my filament lamp. I'm going to have an ammeter or a current sensor. I'm going to put my filament lamp in there. I'm going to connect across it in parallel a voltmeter, and then I need to connect my voltmeter and my ammeter to a data logger. So I know that I'm logging those results. What do I need to vary? Well, I vary my variable resistor, and that changes both V and I at the same time. 3 marks for that diagram, 2 marks for that explanation, 5 marks in total.